All right, so this is Mr. Smith here. We are working in section 5.5, polynomial long division. And we saw a little bit of this yesterday. We're going to pick back up with it today. So, the first thing I'm going to do is calibrate the board. All right. So, the first thing we need to do when we write this out, and yes, I am recording, is we need to make sure that if I'm starting with x cubes, that I have x cubed, x squared, and then I need to leave a space for the x column. Okay, we have to keep our columns, so we cannot forget to leave a space there. And you can either write 0x or you could just draw a line, but you need to leave some way to let yourself know that there should be a column there for the x's. And we're going to divide this by x minus 4. And remember that these problems take up a lot of space, so please accommodate for that. All right, so x cubed, the first division we do is we take this piece, x cubed, divided by x. That gives us x squared. So this is what's going to go in the x squared column. So up here, x squared. Now we take the x squared and we multiply. Take the x squared and we multiply by the x. We take the x squared and we multiply by the minus 4, and we put those results right here. So x squared times x is x cubed. X squared times minus 4 is minus 4x squared. Now we subtract. Subtraction means change all of the signs. So the x cubes drop. I have negative 6x squared plus 4x squared is negative 2x squared. We bring down the next term plus 0x, which obviously isn't going to do anything for us, but we'll bring it down. Now we divide again. The process at this point has gone an entire loop. We've done the entire process, and we're going to start over. Okay. This time, negative 2x squared divided by x. Okay. Negative 2x squared divided by x is just negative 2x. This will go in the x's column. Negative 2x. I take the negative 2x. I multiply back by the x. I take the negative 2x. I multiply by the 4 now. Negative 2x times x is negative 2x squared. Negative 2x times minus 4 is plus 8x. We subtract. Subtraction means change the signs. So here I get negative 8x, and now I'll bring down the 9. The process starts completely over again. Process starts completely over. I take negative 8x, I divide it by x, and I get negative 8. That'll go in the constants column. Negative 8 times x is negative 8x. Negative 8 times negative 4 is plus 32. Now I subtract. Subtraction means change the signs. Negative 32 plus 9 is negative 23, and that is our remainder. So we can either write r, negative 23, or we write it as plus negative 23 over x minus 4. There we are. That's the long division algorithm. That's the process. Okay. The process has a point. We're going to use this idea to solve polynomial equations. Okay. This is a tool. It's a means to an end. The end is to be able to solve polynomial equations. We use this tool, division, to do that. Okay. Let me show the process one more time, and then I'll take some questions. Okay. Sorry. Did we see this problem yesterday? I don't recall. I mean, I'm happy to redo it. I showed this one briefly. Well, let's go ahead and we'll divide here. This is more actually on the realm of application. But let us start by doing the long division, and I'll pause before I continue on with the rest of the problem. So here we have a cubic polynomial, 2x cubed minus 11x squared We're going to divide by x minus 3. Okay. Process 1. The first division, 2x cubed divided by x is 2x squared. This will go in the x squareds column, 2x squared. Now we multiply back through. 2x squared times x, 2x cubed, 2x squared times minus 3, minus 6x squared. Now we subtract. Subtraction means change the signs. This is negative 5x squared plus, go ahead and bring down the 3x. Okay, bring down the 3x. At this point, we've done an entire loop. We've gone through all the steps. Step 1, take the first term divided by the first term here. That gave us the 2x squared. Step 2, we take that and we multiply 2x squared times x, 2x squared times minus 3, brought us to here. Step 3, we subtract. And step 4, we start again. I mean, really, it's a 3 to 4 step loop, and we just keep looping until we're done. All right, so we're starting with the loop again. Now, the first term here, negative 5x squared divided by x, negative 5x. That goes there. It's going to be part of our quotient, negative 5x, right? Because this is just negative 5x. Now I multiply. Negative 5x times x, negative 5x squared, negative 5x times negative 3 is plus 15x. Now I subtract. Subtraction means I change both the signs. This gives us negative 12x plus 36. Okay. So the last division, I've now done, again, another entire loop of the process. The process is looped now. We'll start again. I take the first term here, negative 12x, divided by x. That gives us negative 12. Minus 12 here. Negative 12 times x is negative 12x. Negative 12 times positive, or negative 3 is positive 36. And I subtract, change the signs, and I get a 0 down here for the remainder. So there's no remainder. And what that means is that x minus 3, so let me change colors now, that x minus 3 times 2x squared minus 5x minus 12. If I were to multiply these two polynomials, I would get back the original polynomial that we started with, 2x cubed minus 11x squared plus 3x plus 36. Right? That's what division and multiplication mean, right? If I divide the original polynomial by x minus 3, and I get out this new polynomial, 2x squared minus 5x minus 12, with no remainder, then it means these are exactly equal, right? And if you go back to our example that we looked at with 40, right, what did we do? We went 40 divided by 8 is 5, which implies that 5 times 8 is 40. It's exactly what we're doing here. It's just we're doing it with polynomials. Okay. Let me pause here for questions. We're not quite finished with the problem, but I'll pause for just a moment. Yeah. Okay, so we have done our long division. We've come out with a binomial, x minus 3, times a trinomial, or quadratic, 2x squared minus 5x plus 12. But the problem asks us to factor completely. And from here on out, you should assume that if they ask you to factor, they mean factor completely, even if they don't say it. Even if I don't say it, I mean factor completely. So we've done some of the factoring, but this piece still factors farther. So let's go ahead and factor it. So we have x minus 3 out here. And now we're going to try to factor this guy. So we have 2x and x, plus and minus. And I believe our factors are 12, 4, and 3, 6, and 2, 12, and 1. But start with the middle pair, 4 and 3. And if we go 4 and 3, I believe that works. Let's check it. So 2x times minus 4 is negative 8x. 3x is 3x, so that should give us negative 5x in the middle. So that should work for us. And so now this is factored completely. Okay, that is the complete factorization of our original polynomial that was a third-degree polynomial. And again, why would we want to factor this? The reason we want to factor is because we ultimately want to solve. Okay, so all of this is leading up to being able to solve a polynomial equation. Okay, that's the big picture goal, and we're using several tools to get there. Notice we're using polynomial long division. We're using factoring, our factoring skills. We might have to use the quadratic formula instead of factoring. In fact, you probably will have to use the quadratic formula at some point. And then the last step is if we were solving this, we would have this set equal to 0, and we would set each piece equal to 0. So x equals 3, if we were solving, which will be the next problem, x equals 3, x equals 4, and so forth. Okay? So let's take a look at that idea. So here we go. They ask us to find the zeros. They ask us to find the zeros of this polynomial. Find the zeros of this polynomial. And so let's go ahead and write out our long division. X cubed plus 4x squared minus 15x minus 18. And the question is, what are we going to divide by? So x cubed, x squared, x. Good. So I have all my columns there. What are we going to divide by? So on the previous problem, if you look at it, I'll jump back to it for a moment. It tells you that x minus 3 is a factor. And so we just divide by x minus 3. But on this one, they don't tell us that. All they say is x equals negative 1. So I need to think of x equals negative 1 as a factor. All right, so how could I rewrite that? So if we think about here, well, in this case, if x minus 3 is a factor, then x equals 3 is the solution, right? We've seen that before. If x minus 3 is the factor, then x equals 3 is the solution. Here, if x equals negative 1, then x plus 1 equals 0 must be the factor. So x plus 1 is the factor. Okay, and that's what I'm going to divide by. Again, I realize they're opposites, but we've seen this before, right? For instance, here, if I ask you what are the solutions, well, x equals 4, right? It's the opposite sign of this one. Here, x equals 3. Here, x equals negative 3 halves, right? Because we're just setting it equal to 0. So here, if I give you the solution, if I tell you x equals negative 1, then the factor has to be x plus 1. And so now I'm set to divide by x plus 1. And in all of these cases where we're solving polynomials or factoring, we should expect a remainder of 0. Okay, if we don't get a remainder of 0, then we have some issue because this should go in there evenly. It should go in evenly. So at this point, those of you who are watching the video, those of you in the class, if you would work on this long division and see if you can do it by yourselves, and then we'll pick back up together. Okay, so work this long division out. I'll see how you're doing. Okay? Let me pause the video now. Okay, so here we go. So we start out, and by the way, we're expecting to get a result that has no remainder, a remainder of 0. So if I get to the end result here, and I have a remainder, it means I messed up. Okay, so x cubed divided by x. Well, that's just going to be x squared. And so this number goes into the top here. This is part of our answer. This will be part of the quotient. It goes in the x squared columns. We multiply back. We get x squared times x cubed, x squared times 1, x squared. Now we subtract. Subtraction means change the signs. This becomes 3x squared minus, we bring down the 15x. Now the process starts over, except this is the first number now, and we take this and divide it by this. So 3x squared divided by x gives us 3x. And so this will go right here. Again, this is part of our answer. This is part of the quotient. So 3x times x is 3x squared. 3x times 1 is plus 3x. But now we subtract. Subtraction means change the signs. So now we get negative 18x, and we bring down the negative 18. One last division. It's negative 18x divided by x. Again, this is like scratch work, but it helps you to see where the answers, x squared plus 3x minus 18, where they're coming from. Minus 18 times x minus 18x. Minus 18 times 1 is minus 18. Subtract, so we change the signs, and we get a remainder of 0. Okay. So now we can proceed with trying to solve the rest of the equation. Right? I know one of the solutions already. X equals -1. They gave that to us. Here it is. Right? But I need to get the other two solutions. How am I going to obtain the other two solutions? I'm going to solve this quadratic. Now, in the textbook problems and in this example for sure, that still factors. However, it may not factor. In fact, it's likely it won't. So we'd have to use the quadratic formula. In this case, it does factor, so let's go ahead and factor it. So x squared plus 3x minus 18 equals x plus 6 and x minus 3. X plus 6 and x minus 3. So, what are the solutions to the original polynomial? Right, what are the zeros here that make this thing equal 0? They are x equals -1. That was the one that was given. X equals 3. And x equals -6. And again, you haven't officially learned this yet, but it's a cubic polynomial. So I expect 3 solutions. Okay, cubic polynomial. So I expect 3 solutions. And that's the process. Okay. Now, of course, we can verify this looking at the graph. Right? The graph should intersect on the x-axis in 3 places. If you look at this graph, it will. It'll intersect at -1, at 3, and -6. So we have the graph to help us here. We have the graph to help us here. But I still will expect you to be able to do this long division process and show me that you know how this could work by hand. So let me give you a problem to try by yourself all the way through now. So here we go. Here we have a third-degree polynomial. It's a cubic polynomial, and I tell you that one of the solutions is x equals 2. Okay, so for you to obtain the other 2 solutions, we need to divide out. We expect to see no remainder. And then we'll use either the quadratic formula or factoring to finish it from there. Okay, so if you're at home, you can pause the video now, and please work on this problem. All right, so on the board, you'll see that I've already conducted the long division. I tried to indicate that I changed signs by changing colors here, so if you want to look that over on the video in greater detail, please do so. Again, we expect the remainder to be 0. It is. So this is the quadratic. So x squared minus 2x minus 15 times x minus 2 gets us back the original cubic polynomial. Now, in this case, that quadratic factors more, but I've already indicated that you should expect that it not factor. So let me show you what you would do here. If you get to the point where you get this quadratic and you look at it and you say, I don't think that's going to factor, plug it into the quadratic formula. So x equals -2 plus or minus -2 squared minus 4 times 1 times -15. So it would be 4 plus 60 all over 2. Okay. All right, this is just an application of the quadratic formula where I'm using a is 1, b is -2, c is -15. Okay, that is our quadratic that we're trying to solve now. And so at this point, this is just 64, and of course the square root of 64 is 8. So we get 2 plus or minus 8 divided by 2, and this tells us that 2 plus 8 is 10 divided by 2, x equals 5. 2 minus 8 is -6 divided by 2 is -3. And so there are the new solutions. These are our 2 new solutions. And of course we have our original solution that was given in the problem, x equals 2. And so here are our 3 solutions. Of course, if the problem factors, go ahead and factor it. I mean, don't do more work than you need to. But if you don't see how it factors, or you're pretty sure that it doesn't factor, jump right to the quadratic formula, and it'll work for you. Okay, so this is the big idea of this section, how we can use polynomial division to allow us to solve polynomial equations. Okay. And of course, we could branch this idea out to bigger degree polynomials. If I gave you a 4th degree polynomial, and I give you 2 of the solutions, divide out and get a cubic polynomial. You could divide that and get a quadratic polynomial. And then you could use the quadratic formula. So these problems could be massive, more massive than they already are. I will try to be gracious, though, to you. Thanks for your attention. This concludes Section 5.5.